introduce ourselves. We work at Authenticate. It's a cybersecurity company, and I've been building Flutter apps for over 6 years now. I started in 2018, and we're at Authenticate now.
And I'm Maria. I've been here at Authenticate about 2.5 years. That was the start of my Flutter journey. So you will definitely hear about some bad Flutter practices in the beginning, and then it gets a little bit better. But there are some disclaimers in the early slides. All right, so by the end of this, we have a few main takeaways we want to feel like you guys know. So we're going to talk about Dart VMs, runtimes, isolates, and how they're all connected. We want to talk about VMs and runtimes because it is connected. And then we will talk about how Flutter launches from the native app. And then you'll have an in-depth understanding of how isolates exist, work, communicate, the life cycle of them, etc., and how you can use them, as well as some cool applications of isolates, not just using them, but how you might want to use them in ways you're hadn't heard of before, and then some optimizations that we've learned along the way using isolates, also known as tips and tricks.
All right, so what got us in this situation? We started off with this feature on our app that kind of relaunches the app in the background based off of geofence triggers. So we have it, it's a physical access control app. We have it so that if you walk up next to a door, it looks at the location and then launches your app in the background for you. You don't have to pull your phone out. Which meant we had two different isolates that were running. The default isolate that runs the UI, and then all of our business logic for unlocking a door running on the separate isolate. And when we ported our backend from a REST API to a socket IO, which is a pub/sub model, we kind of realized that, hey, we need this data transferred across both isolates, but there's no shared memory. And the data models that we were using weren't really set up to deal with just communication across both of them. So what we kind of did is we went a little hack fix way around it, and we made our custom isolate the default isolate. We kind of like plug that in from native when it launches. So yeah, we overrode the default isolates main activity in Java, app delegates in iOS, and all of that then kind of just like existed in one single isolate. We do disclaimer, don't do this. This is not the way to do engineering practices for like scalability. Two isolates is the correct way to do this, but at the time it was just a huge refactor, and we found that this was the quickest way to get us on road with our backend refactor. But yeah.
So we keep mentioning isolates. Just to give a little background before we go pretty in depth, we want to make sure everyone has an understanding. So an isolate is an independent worker with its own memory. It's got its own event loop as well. When we're talking about that asynchronous work, this will come into play. We have this so that you can have concurrent execution without shared memory, unlike threads. That also means there's some error isolation for cases where you might have some heavy computation, background tasks, parallel tasks, just to keep the UI smoothness away from those like computationally heavy tasks.
All right. Something to note about isolates is that they get their own memory space, but they also get their own event loops. And for those unfamiliar with what an event loop is basically all asynchronous operations in Dart kind of happen in an event loop, seeing as Dart is a single-threaded language, and if you want to support parallelization, we run an event loop which queues up all of the tasks that you send it. It processes the first one, moves on to the next one, so on and so forth. And from this diagram, what you can see is I have the main isolate that's doing a job of painting the screen. As it's doing that, I get a tap on the screen from the user, which triggers like this expensive computation. Could be like resizing an image, could be n number of things. I want to spawn an isolate to run that callback in its own event loop so that it doesn't mess with my UI, and I'm still allowed to paint and create new widgets on the screen, which means when that result returns, I also need to communicate it back to the main isolate. But yeah, just to keep that in mind, that each isolate does get its own event loop.
So the reason that we want to like kind of compare these is that Dart is single threaded for safety reasons and reasons I'm not going to get into why Dart has these decision making. I'm not privy to that. So we're just going to do a little comparison here. So isolates have, like, you don't have to manage sharing the memory between them. Aniket will talk a little bit about how there could be deadlocks, race conditions with the OS threads, but because Dart is single threaded, you don't have to worry about deadlocks, race conditions, things like that. We will have the problem where it's a little bit more involved in managing the life cycle. So when you spawn isolates, you do need to be sure that you are killing them, terminating them, pausing them, etc. We'll get to code examples of all this. This is just kind of an overview. And I mentioned it before, there's no shared memory. And as a result, you can't just access the same objects like the shared variables, mutexes, semaphores, like you might have in Python, for example. So these isolates will communicate via ports, where you set up a send port, a receive port, and we will get into examples of using those and the type of data you can share between them.
All right. Just a little bit more info on how an isolate gets created. I kind of like to think of it as a puppet master's hands, where one of his hands is the Dart VM, right? And this is what's responsible for creating isolates, for creating threads, assigning memory from the native. So it could be from Java or Android, or Objective-C in iOS. And it assigns and allocates these resources to what are known as isolate groups, or isolate groups and isolates. And then the runtime is actually what's dealing with the life cycle of an isolate, sending control signals to an isolate using its control port. All of that stuff is handled by the runtime. Just another aside here, runtimes do also do something special. They also do type checking. So the runtime will manage all of your types in that isolate. They also do garbage collection, so any unused variables get cleared up. But yeah.
So we keep talking about isolates, so I'm sure you want to know how you make them. There's quite a few ways. You can spawn them. You can spawn URI. We'll get all, again, into examples that you have in Dart isolate.run. Compute is just the Flutter wrapper for that, around that. It'll make managing the lifecycle easier. You can, when you create your Flutter engine, you have that default isolate. So once you launch multiple isolates, I mentioned you have these ports. So they communicate via the send port, receive port, and that is happening asynchronously. So spawning an isolate and sending data using ports enables more thread-safe message passing without that shared memory that we keep mentioning. We also, when you create a isolate, that means you now have to manage the lifecycle. When you, the reason you want that is because if you leave a listener opener that you're not using, or you're not killing isolates, you can actually have some memory leaks, and you just want to be sure that you're cleaning up the resources that you're not using. And we will go through exactly what I just mentioned in examples of creating, interacting, and then the lifecycle. Oh, sorry. And the Flutter app runs on the UI isolate by default. So when you launch your app, that is the UI isolate, and then you can run other isolates concurrently to communicate via port, because you don't want to block that. You don't want to block any rendering or user interactions on that UI isolate.
All right. If we just look at the code, that really simplifies how you create isolates. The most basic way of creating an isolate is just to call isolate.run. It's going to manage the lifecycle for you. It's going to create the isolate. It's going to set up the entry point. It's going to tear it down when the entry point function is done. It returns. So I have examples here of a function called heavy computation. All it does is sums number up to 3.5 billion. The main computation does it up to 5 billion, so kind of longer than that. And on the left there is the flow that looks like if you weren't to use an isolate and wanted to do both of these computations, you have to do them serially. So you run the heavy computation and then you run the main computation. I have the results there. The heavy computation took about 3 seconds. The main one took about 6.6, adds up to 9.6. If I were to use an isolate now, so on the right, I do an isolate.run heavy computation. It immediately starts running the heavy computation in parallel with my main computation, and then I just await the result of it um, just below main computation. And so even from the logs, you can see that the first line that runs is starting program, heavy computation starting, because it immediately starts as the run function is called. The main computation starts after that. The heavy one finishes first, of course, in 3 seconds. The main one does continue for another 6.6, and the total program execution time is now 6.6 because we weren't blocked by the heavy computation. Um, the equivalent for that in Flutter is just the function compute. It's just a wrapper around isolate.run. It does the exact same thing, but you can call it from Flutter. And then this is like a demo app where if you press the button, that's going to start the same computation. And in the meanwhile, it's going to show the text said calculating. I have it on set state result calculating. And then at the end, it displays the sum. Compute takes the arguments. The first argument is going to be your entry point, and the second is going to be any arguments you want to pass to your entry point via this isolate launching process. The next way of spawning an isolate is something that's kind of natural sounding to me. Is if you had an isolate that was doing its own processing, it would also be in its own set of like source code, its own separate memory, its own separate files, however you want to structure it. So I'm having this test worker.dart, and this is my worker isolate. This is gonna define its own data types. It's gonna come up with its own stuff. It's gonna have its own event loop. It's gonna run completely parallel to main.dart. And this is what is essentially our old code base used to look like. Is we had these files doing all the business logic in this worker isolate, and then there was the main isolate showing the Flutter UI. Something to note here is because these are two separate code bases, there's different source codes. You can't really send an object of type that's defined even in both those code bases across these isolates. So you see this class car that I have defined. I try and send that over the send port, and it's gonna error out saying that, hey, this is an undefined or like this is not an reachable instance. But if I were to then say send a map representation of it by calling car.toMap, which just makes a map string comma string and then sends that over to the other isolate, that's going to work just fine. So something to note is if you spawn an isolate via spawn URI, you're going to have to use native Dart types, not your own custom data types. A way to work around that would be to use it in the same code base by calling isolate.spawn. And now, because both those isolates share the same source code, they share the same objects, they share the same symbols, they do reference each other, and you can send basically objects of the custom data classes that you have. Another little thing to note, I just spoke with the author of typed isolates. They do type checking on these isolates. So I mentioned that you're able to send primitive data types, but if you wanted to like restrict it and type check it to your isolate, you could use that package also.
So after you create these isolates, you may want to interact with them in different ways. So if you're manually controlling them, you can pause and resume it. If you try to pause an already paused isolate, I believe there's not actually an issue. Same thing for resuming. And how it works is that you have this control port that's used to listen for these events in the isolate that we're talking about. Yeah. And, oops, sorry.
Yeah.
So I mentioned earlier you can pause, resume, but it's really important that if you are manually managing the life cycle of these, you want to make sure you kill the isolates as well and clean up any resources. So here in this first example, I spawn an isolate, I do the work that I need to, and later I kill it immediately, but you don't have to do so. You can actually pass in different arguments like before next event to delay until the next event loop turn. So if you know there's something in the queue that you need to execute and then you want to kill it, you can do so. You'll also notice here with the port, I closed the port. You don't want to leave that listening. You can end up with a memory leak that way. So in the final example, I kind of just combine it all. I await the result, I close the port, and then we kill the isolate. Again, this is for where I'm spawning it myself. For a function like compute, you'll notice you didn't have to kill it in the example Aniket showed, because that is managing its own life cycle. Yeah.
Just a little aside again on the pausing of an isolate. By default, if you have an isolate that you're trying to pause, it's not going to pause any executing functions right away. So if the function is executing, that's still going to continue. What you're pausing is the event loop, and it's not going to process any further events in that event loop. So say you had like an extremely heavy computation already running, you're not going to be able to just sleep that function call. But yeah. All right, I can do this one. All right, we can now talk about how the default isolate gets created on both native iOS and Android. The execution flow really starts from what is called an activity in Android and an app delegate in iOS, where they manage the UI life cycles of an app. And you can have multiple activities, you can have multiple app delegates per app. These would just be your screens that you go through on your app. So if you had a native app and you wanted to use Flutter in there, you could just create another activity or an app delegate and create a Flutter engine, and then start using all of the goodies that Flutter affords you. I just to reiterate on that, you can integrate a Flutter engine into your main activity or your app delegate, and that's gonna allow you to run Flutter.
So we have an example of that, but we want to just be sure that we know we're Flutter developers here. So you might be wondering, like, what is the app delegate? So in that main.m, you have a central entry point for the iOS app. That's what's managing the app lifecycle. So events like launching, entering the background, receiving notifications, terminating, all of that sets up the UI and the service. So you can think when you run the main function, that is creating a UI application main in the iOS code, and then within that you have an app delegate. And so we're mentioning that because you need to know how Flutter bridges the gap to that. So you have a Flutter View controller. That's the native iOS controller that actually renders Flutter's UI. So this is what's kind of taking the app delegate creates the Flutter View controller, and then puts in that window so Flutter can take over the screen. So that is where the Flutter UI that entry point takes over. Just to note, you can start and stop rendering whenever you want. So that's matters for if you're kind of adding Flutter to a native app. That's where that would come into play. And so Aniket's gonna we have an example here. Hopefully that's big enough to see.
All right. So this is a simulation of what's actually going on under the hood. I'm sure none of this exists in your regular code if you're just trying to write a Flutter app. But this is what's essentially going on under the hood. Is we set up what's called a method channel in your native, and this allows your native code to communicate with your Dart code or your Flutter code. And so you set up these listeners, these method channel listeners. Then you go on to create your Flutter engine, and there's parameters like allow headless execution, which means It allows you to run the Flutter engine, which is run the Flutter framework, but I'll also let it pause or stop the rendering and then resume it as you see fit. Um, Once your engine is created, you assign it to your view controller, you set it in your window and you make it visible. And then what you do need to keep in mind is you have to register your isolate with the plugins. If you don't do that, you're not going to be able to use any of your native plugins in your isolates. You're not going to be able to use tools like FFI, what have you, FCM, stuff like that. So yeah, that's what it's going to look like.
So of course, Android has its own version of that. So before we understand how Flutter bridges, we'll talk a little bit about the Android. So it has an activity, and this is the class that's representing the UI screen in the Android app. So we're talking about the lifecycle where a component that draws the UI, handles user interactions, coordinates with the app lifecycle, etc. And so the way that iOS has app delegate as its main entry point, Android has main activity as its entry point for the UI. And this can be a subclass of Flutter activity. So this is the activity that hosts the Flutter UI inside the native Android app. So this is what's going to run the Flutter engine, the Dart code, and just acting as the bridge between the Android platform and the Flutter UI.
All right, before I start talking about this code, I'm sorry about that. There's a bit of like complex hackery going on around here. But if you want to recall the iOS example, we're going to do essentially the same things. We're going to set up a listener, we're going to create the engine, and we're going to register the plugins. Now, how this differs from the iOS implementation is when in iOS, we just attach the engine to the window or like the Flutter view controller. On Android, we attach it by a cached engine ID. So what I'm essentially doing here is I'm creating the Flutter engine, putting it in a cache, giving it a key value from there, and then the main activity or like the Flutter activity is going to look for an item in that cache. If it doesn't exist, it's going to create it. If it does exist, I'm just going to use the same one. And where this played into with our application was with geofencing. If I already had a version of my app running, I don't want to again launch another Flutter engine. So I just look up at my cache. If it exists, I just keep using that, and we just go from there. But that's the only difference between this and the iOS code. The rest of it, all of it looks similar. There's a method channel, there's a plugin registrant, and yeah, that's it. All right, so here's some of the cooler applications of isolates other than just like parallelization, which is what one of these is what we do is geofence triggered Flutter engines or geofence triggered launching isolates. There's other triggers that you can use, like an FCM notification trigger. And obviously now, if the point's driving home, you can set up any kind of trigger to it. You can set up background task handlers. You can trigger an isolate from another isolate. You can just chain these as you see fit. If you also wanted, you could set up a cron job. Hey, 2 p.m. every day, I want this little task to run in Dart, whatever. But yeah, these are some of the cooler applications of isolates and launching them. And this is where you would use like launching an isolate from native. Oh yeah, okay. So certain tips and tricks and little gotchas around isolates that aren't super duper obvious. When you do close an isolate, you also need to close the listeners for it, like cancel the listeners for it, because the listeners also get their own memory allocation. They also use up CPU cycles, so you want to make sure you cancel those. Error handling is something that you have to do manually. Any uncaught errors, and this is important, any uncaught errors in an isolate will pause or terminate it if that isolate does not support a pause capability. And you really don't want that happening if it's like a long running task, you left that running, an uncaught error, and boom, now you have to do the whole thing again. Um, Another thing to note, you also have to register plugins. I already talked about this. And the final thing is, so recall when we spawned an isolate with isolate.spawn, even if it is in the same source code and it has references to the same objects, there's still separate memory spaces. So when you try and send data from one isolate to another, it's not actually just going to access the same data in memory, it's going to create a copy of it. And so you want to be very careful with what your data is structured like, because that's going to be a huge bottleneck if you're communicating across your isolate pretty often. I'll let Maria talk more about how you want to structure your data, though. So yeah.
Thank you. Okay. So because it's a deep copy, this is kind of this should actually say the native Dart types across the compiled code. So you want to make sure that when you're creating your classes, that even if you do have one isolate, if you think in the future that it might be separated, you kind of want to plan for that. So you might, if I have it here, an efficient way to do that would be using protobuf. I'll kind of give an example of that in the next slides. But in this case, protobuf is you can write to the buffer binary data, and that is much smaller. So we mentioned earlier a bit of a speed issue. This will help with that. It reduces the overhead. And when you read from the buffer on the other isolate, it's much faster than the JSON. Let's see. So this is just another example of what you can do to kind of prevent like UI jank. Let's see. And again, this is just for code that's in two different isolates, different memory. If it was the same memory, the definition for a class would exist and it would be fine. But I speak better in code, so let me just show that example. So we have a pretty simple resource. So we do physical access. So we have a resource that has an identifier and these different properties, for example. So before, you can, in a very slower method, would to be have this to JSON where you yourself are serializing it, and then when you'll send that object, that encoding, when you send through the port. On the other end, you will be receiving that, you'll be reading from JSON, which is fine. You can do that, but there is a much more efficient thing to do. So you can see here that I've used protobuf on the right to create this protobuf state. And what that does, if you see the write to buffer, will just return you a list of data. So it still can send through the port because it's just a list, but it's much faster. Yeah, sorry, it's still on the slide. So it's much faster to write the data and read the data than JSON serializing it. This also is good if we work with different backend, different language. So if you have objects that you want to define in other languages, protobuf is just a good option as a default anyway. You can use message pack if you're just doing Dart, if you're not worried about like cross language, but in this case we wanted to use protobuf. And just as an example, this is like what protobuf you write, and then you just activate proto-C and it will generate the code before. And so what's really nice about this is that you can have these like bool strings, but you can also have as a property another message. So maybe if you have a class that subclasses another one, you can use messages in protobuf to deal with that. This isn't a protobuf talk. We don't have to talk about more protobuf stuff. But here is an example of what I mean. So did you want to talk? Okay, so it's very similar to the other examples that Aniket showed already. My mouse working? Okay. We create the port, we spawn the isolate that we want to do the data manipulation or whatever you need to do there. So it's when we write to the buffer, it gives us these bytes, and that's all you have to send through the port. It's much faster, so write to buffer and from buffer takes about 1 to 3, if you give it the same, about 1 to 3 milliseconds, I forget what data size I passed, but that same thing for JSON encode or JSON decode would take about 5 to 10 milliseconds, which doesn't seem like a big difference, but if you're doing something very often, that all adds up. It's very important. And it's important to know, other than being faster, it's much faster to parse is very important, not just to send. And I have like full keys. You can make this even faster by doing like just a U, just a C, just an A. I just like to be able to read my code. Um, and you can actually like enforce types as well when you're using protobuf. And so even if you aren't speaking with other languages, it makes it much easier in isolates to make sure you're using the same class reading and writing. Oh.
Okay. Now I know we mentioned communicating with ports on isolates, but the terminology around it is really confusing, at least for me when I was first getting started. So I just want to add a little note on there. There's two ports that you need to worry about. There's a receive port and a send port. You use the send port to send data to an isolate, and the receive port is where you would listen for data on that isolate. And so what we're doing in all of these examples is you'll see the isolate.spawn, the second argument is a send port. So I'm sending my send port to the other isolate. It uses that to send me data back, and vice versa. The second isolate that's created will have its own receive port. It will send me its send port, and I will. So you really want to be careful with the variable naming in your code about this. It's really tricky, but yeah, that's the general gist of it. Is there is a receive port, a send port, and obviously the third one is a control port, which you'd use for pausing, resuming, and sending interrupt signals. You want to wrap it up? Go ahead.
I don't have anything.
Okay. All right. And yeah, that was it. Any questions?
We just did 2 again.
Hello, great presentation, by the way. So one thing we deal with the mobile Flutter apps that we make is, so we have a location tracking in an isolate, but oftentimes we have trouble with Apple and Android killing the tasks in the background. Okay, it's not just me. Perfect. Yeah, but how do you deal with that? What advice do you have for our team?
Yeah, that's a great question. We had like another talk. We could just do like so much about this, but our first initial solution to that was geofencing, where if you do have OS pressure, memory pressure, you just do it off of location. Caveat: it does require the user to give you like location always permissions. It's really something that privacy-minded people will not be. It's also a huge like battery usage. Other techniques that we had was literally just being mindful of what the battery level is at on the phone. If you do know that and you can just send like a notification, it's helped the OS be aware that, hey, this is an application that's still running. We don't need to kill it just yet. There's certain Android manufacturers that allow you in their settings to whitelist an app. You could just be like, hey, this app, don't kill it. I think there's a Samsung that did it. I can talk to you about the specifics on that later, but yeah. But yeah, that's it. There's a bunch of ways. Of course.
You just did 2
Okay.
again.
All right, no more questions? The organizer is going to help us.
Okay.